I love that shit. You download a game just to pass time somewhere, and the game's like, "Play me, get away, go."
I should delete all my games.
If you don't know what I'm talking about, then you probably lead a more productive life. Okay. So here's the form. I'm not going to write all of this out. Blah 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 blah. Plus a0xy equals 0. So that's an nth order homogeneous linear DE. Cool? Okay.
A to 0 or A to 1?
A0, because it's related to the derivative. You with me? So this is like the 0th derivative. No derivatives have been taken. I like it. So there's a theorem, an existence theorem. This is really funny. Oh, I have to put up here also. Okay, I like it. So you gotta love this existence theorem because there's a lot of conditions already on this thing. Inherent in what this says. It's gotta be linear, it's gotta be homogeneous, so forth. This says that there does exist a specific YC, which is the collection of all these. Right? It exists. There exists a unique YC. There exists like a how do I want to say this? Ah, that's better. There exists a fundamental set of solutions. There you go. For I'm going to put it's little 6. It's equation number 6 in the section. There exists a fundamental set of solutions for this. On some interval, period. That's the best existence and uniquest one we've seen yet. If you look back at the other ones, they were much less restrictive on how they defined what kind of DE we're looking at. This one's so restrictive, it's like, well, it's gonna work. Okay. Oh, okay. Last little thing. Do you guys remember we talked a little bit about the superposition principle?
Yeah.
All right, and all that said was, if you have two solutions to a second order, then any linear combination of those two is also a solution, right? So what we normally do, if we find those, what we normally do is we collect them together as YC. That would be the solution to the homogeneous part of the DE. Yes, sir.
The superposition principle only applies to linear Ds.
For the moment, I think they were specific.
Yeah.
Yes.
Okay.
Nth order, wait. Oh, no. Yeah, they do say linear. Yeah. So later we have to see, okay, we'll start to explore certain types of nonlinears, and then they'll each have their own possible thing. But right now, to be really careful, we just say it's got to be linear. If it's not linear, there's a lot of shit that could happen. So then certain forms will have certain things we can say.
Okay.
Blah, 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 blah. Okay. Just like we talked about with homogeneous, the non-homogeneous stuff is very similar. Take this away. This is, by the way, this is frustrating for me also because a lot of what I'm saying is going to make sense when we actually start solving problems, because I think I told you, if I have a DE that's equal to, is that still going?
Yeah.
Hang on. Maybe I did delete this stuff. Okay. If I have a DE that's equal to like 7x, right? Would that be homogeneous? No, because it's got a g of x in it, right? So it's not 0. What I would do is I would solve this. You guys remember this? I would solve this. We call this the associated homogeneous differential equation. I'm being very careful. I call it the assoc-homog. It's really touchy if you go too far with I just want to stay away from it. But it gets really annoying writing all this shit down, right? Megan just call it the and then from this, when we solve this, we get our YC. Now, YC could have a lot of parts to it, depending on the order of this thing. Are you with me? YC could be C1 and Y1, C2, Y2. If it's first order, it's just C1 and Y1. And then I got to figure out what makes this work. Just like what I pointed out earlier. So I had a YC piece, and then I had a YP piece. And it's a particular solution. It's got to be the thing that makes it 7x. That's why it's not going to have any constants on it. Because it's the thing that makes that work. Okay. Maybe. So, what's up?
Go ahead.
Thanks. So if you have a non-homogeneous DE, it's going to look like, the solution is going to look like y equals yc plus yp. The problem is going to look like, just like a, I'm only going to do so many of this. But now it's got g of x instead of 0, right? So this yp is the thing that when I throw it in here, it makes g of x happen. And all this stuff does is make 0. So it doesn't affect it. So watch. Let me use you remember what this is?
Oh.
It's all this shit, right? So if I act on yc plus yp, well, what's L of yc? It's linear, so I can do that, right? That's why I give it an L. That is 0. And that is g of x. There you go. So that's why, if I can figure out everything that makes it 0, I can add to it the thing that makes this happen. Where'd it go? Because these parts won't screw with this part. Just kind of get out of the way. There's 0, 0, 0, 0, 0, plus the thing that makes that happen. Okay, cool. That's why there's always those 2 steps when I have a non-homogeneous DE, which is why we study the hell out of homogeneous stuff first. Because the first step in this shit is going to be this, right? Figuring out what this is. Okay.